Okay, so now what is the 3 momentum part of this equation tell us? It says that Q1 plus it says that Q1 plus Q2 is equal to 0. Q1 plus Q2 is equal to 0. Okay, so that implies that Q1 is equal to minus Q2, and we'll just call that Q. Okay, so this is the magnitude of the 3 momentum of each part of each of the ejecta particle. Okay, that's the magnitude, and they have to be the same. Doesn't mean their velocities have to be same if they have different masses, but these are the magnitude of the relativistic 3 momentum of each particle after the decay. Okay, now we can use the energy momentum invariant, which we've talked about a number of times, to give general expressions for E1 and E2. Okay, so E1 squared is equal to m1 squared c to the 4th plus q squared c squared, and E2 squared is equal to m2 squared c to the 4th plus q squared, that's a q, c squared. Okay, so we have that we can E1 over c is equal to m1 squared c squared plus q squared, and E2 over c is equal to m2 squared c squared plus q squared. That's all under the square root, sorry. So in principle, this is what we'd plug in here. So we would sum those two expressions, which I just wrote down for E1 and E2, E1 and E2 over c, okay? And we would equate that to big MC, okay? And that would allow us to solve for Q, okay? Because if you look at it, we know M, and the expressions for E1 and E2, we know we know M1 and M2, so we could solve that for Q. However, so let's just write that down, okay? Just so we have it down very clearly. Okay, now the problem is that this is a pretty difficult. So again, we would solve for Q, and then after we solve for Q, then we can plug Q back in here, plug it back in here. That would give us the energies. That would give us everything that we needed to know. We could eventually solve for the velocities and whatever. But this is a difficult equation to solve analytically. You can do it, but it's difficult because it's quartic. But we can consider a simpler case. Okay, so let's consider a less general case. Okay, that is where m1 is equal to m2 is equal to m. So we just consider the case when both of the particles have the same mass. Okay, and there we get. So now let's we have again before the decay we have our 4 momentum is like this, and after the decay now we have 2e over c and also 0. Okay, and we can even ask what is the speed of the ejecta, for example. All right, and it would be reasonably easy to find that. Basically, you use energy. MC is equal to 2e over c, where E over C is equal to gamma MC.